Right now I'm going to go over simplifying radicals with variables. So we've been over entire and mixed radicals with only numbers, right? But what happens when we have radicals with variables on the inside or outside? So for this first one here, simplify, what would we do if this was the square root of 9? Okay, so let's say the x wasn't there. If this is the square root of 9, right? We know that 9 is the same as 3 times 3, right? And we know that there's two groups of 3's multiplying here, or a group of two 3's. So we would take one out, and we would have 3. We wouldn't be left with anything inside the radical, so our answer is just 3. Right? So if we have the square root of 9x, that 9 is still there, except we have to look at the x now. So we don't have a group of 2x's multiplying, or a group of 4x's multiplying. We only have one. So the square root of x, right, if we were to take out the 3, because the square root of 9 is 3, we're left with the square root of x. We don't have multiple or even a single group of 2x's, so our answer is just going to be 3 root x. Okay, if this was, for example, the square root of 9x squared, well, the square root of 9 is 3, right? And x squared is just x times x, so there is a group of 2x's there, and the square root of x squared is just going to be 3x. Okay, but for this example, that's not the case. We just have one x. We can't bring any x's out. Our answer, I'll write it a bit lower, is just going to be 3 root x. Okay, let's look at the second one here, 24t cubed. Okay, so we're going to focus on one thing at a time. So let's focus on the 24, and then after that, let's see the t cubed. So we have to think, what would we do if this was the square root of 24? Well, 24 is the same as we could do 2 times 2, which is 4 times 6, right? So this is equal to, we have a group of two 2's, so we take out one of them, it would be 2 root 6, right? So in terms of the numbers, we're going to have 2 here, and then root 6. Now let's look at the t cubed. So if this was just the square root of t cubed, right, this is equal to the square root of t times t times t. So see how we have 2 t's here? We can take out one of them. This is the same as t root t. Okay, so this is going to be 2t on the outside, right, because we have one t that we can bring out. And since there's 3 t's, we can only take out one group of 2 t's, and we're left with 1 on the inside. So your answer is going to be 2t times the square root of 6t. Okay, and a quick little trick, let's say this was t to the 12th power, right? Let's say we had t to the 12th power. If this is an index of 2, right, square root, we take this exponent on the t12 and we just divide it by 2. Okay, so this is going to be same as t to the 6th power. Because t to the 12th is the same as t times t times t dot dot dot, right? 12 times. So there's going to be 6 groups of 2 t's because we have 12 in total. So there's going to be 6 groups of 2 t's. We can pull out 6 of them, right? Because we have to divide it by 2. We're just going to have t to the 6th. So this is your answer right here. And you know you did your answer right if you can't simplify the inside of the radical anymore, right? Because we only have 1t, can't square root that. And 6, the only factors are 1 and 6 and 2 and 3. Neither of those are perfect square factors. So let's look at this one here. The fourth root of 32a to the 15. Okay, so if it's the fourth root of 32, we know we're looking for groups of 4 in terms of when we divide 32 by some number. So actually I'll write 32, right? That's the same as, anytime it's a big index like 4, right? I don't really know like 3 to the 4th, 2 to the 4th, kind of just looking at 32. So let's divide it into 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32. So anytime you're not sure like what to do with this fourth root here, just split it up into super small factors like 2. Okay, so 32, it's an even number, and now I can divide it by 2 multiple times. So notice how we're looking for groups of 4. There are 4 2's inside here. So if we take out all 4 of them, we're going to have 2 on the outside. Remember, it's the 4th root. Going to have 2 on the outside times the 4th root of what's left, which is 2, right? Because there was 1 left over. We had 5, we only needed to take out 4. So 2 times the 4th root of 2 is what we have for our numbers. So I'll write here 2, I'll leave a space there, times the 4th root of 2. Okay, and remember, a to the 15th, the 4th root of a to the 15th. Remember, we have to think, how many groups of 4 a's can we fit in 15, right? Because a to the 15 is just a times a times a dot 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 times 15. So we're multiplying a by itself 15 times. Well, 15 over 4 is going to be 3.75. So we can fit 3 full groups of 4a's. Okay, so if we took out a to the 3rd, right, we'd be left with 4. So if we took out 3 groups of 4a's, that'd be 12, but we have 15 a's. So if we took out 12, we have 15 total, there's going to be 3 left. Okay, so if we were to move this a to the 3rd back in, we would multiply the 3 and the 4 together to get 12, and then 12 plus 3 on the inside there is 15. So it's going to be a cubed on the outside, a cubed on the inside. So 2a cubed on the outside, 2a cubed on the inside, which is ironic. But if you're ever not sure if you did it right, you can take this mixed radical and bring all this stuff back in. Make sure you get the same thing as what you started with. So that's your answer for part C there. Okay, let's do some more. So this time we're not just simplifying a single term, we are adding them together. So the square root of 2, can't really do anything with that, but x squared, right? The square root of x squared is just x. So we can bring out a group of 2 x's, we just get x root 2. Okay, the square root of 8, well, remember the square root of 8, that's the same as the square root of 4 times 2. The square root of 4 is 2, so we can bring that out, we can get 2 root 2. So it's going to be plus 2 root 2. So right now we haven't combined the terms, we just simplified like we've always been doing. But notice how this is a root 2 and this is a root 2. So we can think of that root 2 as like a variable, as something, right? Just a way to represent a number. So if we have x of some number, root 2's, and we're adding 2 more of those root 2's, right? We can just factor out a root 2, and we get root 2 times x plus 2. So whatever x is, we can add 2 to it, multiply by root 2, it's going to be the same as x root 2 plus 2 root 2. Okay, so this is going to be your answer right here. This question here, the square root of 125p to the 4th q cubed minus the square root of 5q. So remember, let's break it up into numbers and variables. Let's not focus on 2 things at once. So the square root of 125 is 25 times 5, which is nice. So this is 25 times 5. Notice the square root of 25 is 5. So if we bring that out, it's going to be 5 root 5. Okay, so 5 root 5 is the number portion of the left term. So 5, I'll leave a space, square root of 5. Make this a bit longer just in case. Okay, now let's do the p to the 4th q cubed. So the square root of p to the 4th q cubed. Let's focus on the variable portion of the left side. So p to the 4th, right, that's just p squared times p squared. So there's 2 groups of p squared. That means that we can bring out a p squared. And q cubed, remember that's just q squared times q. So there's 1 q squared here. If we square root that, we'll just get q. So we can bring out 2 p squareds, right? And we're just going to get 1 p squared on the outside. And then we can bring out 1 q squared. So that's going to be p squared q. What we're left with is just this q on the inside. So it's going to be p squared q root q. So I actually have to move this over a bit. 5p squared q, right, root, and then we got 5 still on the inside, 5q. Okay, and the square root of 5q, that's already simplified, so we're going to subtract the square root of 5q. notice that both of these are the square root of 5q. So that means they're like radicals. That means we can, in fact, combine these if there's a plus or minus sign between them. So there's an imaginary 1 in front of this square root of square root of 5q. So we can factor out a 5q, right? Square root of 5q. Square root of 5q. And 5p squared q is the coefficient on the first one, and then minus 1. Okay, so the reason it's like this is because if we were to multiply these back in, right, we'd get 5p squared q times the square root of 5q, which is good because we started with that. And then 5q square rooted times negative 1, this would give us minus 1 times the square root of 5q. So even if they didn't write the 1 there, right, there's an imaginary 1 as the coefficient in front of the square root of 5q. Okay, so yeah, those are just a few examples. Nothing too crazy, just with variables. Remember, we always have to look at kind of them in terms of groups, right? And if it's, say, the cube root of t to the 6th, a quick trick is we take the 6 and just divide it by the index. So this would be t squared. That's an easy way to do it. And it's not always going to work out perfectly. Let's say it was the 5th root of x to the 12th, right? 12 over 5, we can't do that, right? We can technically write it as x to the 2.4, right? But we want the exponents to be positive whole numbers. So 12 over 5, we can fit 2 groups of 5 in there. So that'll be x squared, right, times the square root. But there's still 2 left over because 5 times 2 is 10. We want 12, so it's going to be x squared times the square root of x squared, or not the square root, sorry, the 5th root. Okay, so just kind of an overview. Nothing too crazy. I feel like once you know how to simplify radicals with numbers, variables, honestly, I find it a bit easier because we're not even dealing with like big numbers anymore. We're just thinking of the variables in terms of groups. Okay, so drop a comment, shoot me a message if you have any questions, and in the next couple of videos, we're going to expand on our knowledge of variables. So thanks for listening.